Everyone, so now we're gonna solve this question, reverse pair. So it's a Leetcode 493 question. What the question says is that we have given an integer array nums, and we have to find the reverse pair. Okay, the number of reverse pair. So number of reverse pair means that it's a pair such that ij, where I should be smaller than j, and it should be within the range of the nums array length, and it's such that the nums I should be greater than 2 times the nums j. It means that j is greater than I, but the nums I should be greater than the 2 times the nums j. Okay, so it means that let's say we have the 3, then here 3 and 1 can be I believe a reverse pair, because 3 is greater than 2 times the 1, and similarly also this 3 is greater than 2 times the 1, but this 2 1 cannot happen, or this 3 2 cannot happen, because they cannot they are not greater than 2 times this the nums j. Okay, 3 is not greater than 2 times 2, which is 4. Okay, so here the only answer is this 1 index and the 4th index, and similarly the 3rd index and 4th index. Okay, so let's start solving this. So what we can do first, so we can start like okay, for every ij, I think for every all of these arrays, so for every I, what we will do, we will check for all the j which is smaller than the 2, which is smaller than half of it. Okay, or we can also do it reverse, like let's say for every j we can check for all the elements whose index is less than this, if it is greater than 2 times it. Okay, so I'm gonna do it from the beginning only. Okay, so for I in range of len of nums, okay, and to -1, because why I'm taking why I'm going only till the last element, because we know we have to keep the I smaller than j. So if the j is the last element, so I can only come up to the second last element, so I will be only traversing I till the second last element. Okay, so also the complexity of this question is 5 into 2 to the power 4, so we can go into n log n, I believe. So let's see, first we go with an approach of the n square. So that I said that for every I am checking for traversing for every j, so if it is less than its half or not. Okay, so let's start for j in range of len of nums. So what j should be start with I plus 1. Okay, and then what we'll do, we'll check if it is greater, and it can go up to the length num, and what we'll check that if so what our answer is, let's say, so our answer start with 0, that currently we have the 0 reverse pair. So okay, actually what we have to do, yeah, we have to just to print the number of reverse pair. Okay, so what we will do, that if nums I is greater than 2 times nums j as written in the question. Okay, so if it is the case, then our answer will get incremented by 1. Okay, and this way we should get our answer, right? So now if I return this answer, so that should be answer. But the problem with this approach is that, okay, this is using an n square approach, but we have to solve it in at max into n log n from the constraint that I can see. Okay, so now I can start with what I can do, I can use a dp here probably, I think. Let's see if that works. What I'll do, that for every index, if we are traverse, let's say we have some value, we have a value, let's say 25, and let's say 12 and 5 and 2. Okay, so what we can see here, that okay, 5 2 is a reverse pair, so 12 5 will be reverse pair. So if and 25 12 will be reverse pair. So if we know that 12, if we know number of reverse pair of 12, from there we can know the number of reverse pair that I could generate. Okay, so what we can do, we can store the number of reverse pair. Okay, so what we can do, we can start from the 2 5, and if 5 have like from the 5 I index we have one reverse pair, so we can assume that from the 12 if we have 5 as a reverse pair, 5 is smaller than half of it, so we can assume that the all the reverse pair that is coming from this element is also true for this one. So what is there in that case, that we will add 1 plus reverse pair of this element into the reverse pair for every I, so that will be true. However, there will be a catch here. Okay, the catch here will be that, okay, so 3, let's say if you have 3, so 3 and 5 won't it won't be a reverse pair, so in that case, but it will be reverse pair for 12 as well. So how do we determine that? Okay, it is not creating the problem out there. Okay, so that actually I don't know like how to proceed with here, because what I think that, okay, we can take it a 5, but we cannot take the 3. So I don't know, so let's see the hint. Okay, so the hint is saying use the mud sort technique. Okay, so okay, I think probably something can be done with the mud sort technique. It is like, let's say okay, let's say we divide it on the basis of the index, and okay, and let's say 5 3 and 2 are there. So what we can do, maybe we can run this using the I and this using the j, and for every I we traverse the j until we find that 2 into like array 2j is smaller than like array 1I. So till then we will be traversing the j. I think here it is being satisfied. Let's say the answer would have been different. Let's say we have 5 here and 12 here. Okay, so in that case for 25 it will be true anyway. So in that case what we will do, we can store the value. Okay, we can store the value that, okay, if so as this array will also be sorted, like reverse sorted, so we will also be reverse sorting while the merging. So if we reverse sorted, we will be knowing that, okay, all the elements below it are also satisfying. So in that case what we can do, we can just do the size. Let's say the size of the secondary is m, so m minus our j value, and I think that and that we can store in our answer array or count array. That should solve the problem. Let's implement it, and then I think there will be better understanding. Let's try. Okay, so for reverse sort, like we have to do the two part. First part is the split part. Okay, so the split part consists of so it will consist of, let's say, the first starting index, end index, our array which is nums. Okay, and so I think this much, and it would be returning in my belief an array only, like list of n. So let's also put parameter in here. Like in Python this is not necessary, but if it is being followed here, so we should also follow here. So what we do, we can do split. So for the splitting, let's say first the thing is that till what point we will be splitting. So we will be as you know, in merge sort we will splitting till we find I is equal to j. In that case we simply return the nums I, okay, in the form of an array. That's it. Now the other part is that we can so if it is not the condition, then what we will do, we will have to split the current section into two halves, so we'll find the mid will be like I plus j, it's half. And okay, so our first array will be, let's say, self dot split, and in that we'll go from I to mid nums. Okay, and array 2 will be again from the mid plus 1 to j of the nums. Okay, and then what we do, we merge that. Okay, so we get our final array, and how do we get it? We merge the array 1 with array 2. Okay, that's correct, I believe. Or we can also just simply, I think, pass. Okay, as it will be in this, so first pass is self, and then we can also pass our I value and j value and the mid value, because okay, from that also it will be easier, and our nums. I think array 1, array 2 do better because they are sorted. I was thinking differently. Okay, so this would merge our array, and then we can return this array. This is how we perform the merge sort, and we will write now the code for the merge. Array 1, array 2. Okay. So what do we do in the merge? That we take an I and j and start them from the beginning index, and then we run while I is smaller than like length of array. Let's take n comma m is equal to len of array 1, len of array 2. Okay, so it's easier to understand. While I is smaller than n or j is smaller than m. Okay, I think n would be better, because other than we will be just adding it to the newer array. So we will have new array which will be empty now, and we will adding the current value into that array. So if it is the case, then here what we will be checking, if array 1 I is smaller than array 2 j, then in that case newer array will be adding. Okay, we want to reverse, right? Because because the value in the beginning should be larger, so it's better to take the reverse one. And what we will be doing, the adding array I, else we will be adding the value from the array j, and we will increase the value of the I, we will increase the value of the j. So this is how our array perform, and when it will reach any of the terms, let's say I reach to the n or j reach to the m, so in that case what we will do, we will simply perform while I is equal to smaller than n. If it is reached the n, then this loop won't run. Otherwise we can just simply one of them will be n, so you don't need to worry about the other ones. So new array, and we will just be adding array I. So if it's if the second array has been traversed fully, so now all the small elements are in the first one, or if the first one has been traversed completely, then in that case all the smaller element will be in the second one. And as the second array is already sorted, so we don't need to worry about it. And then that's how we perform the merge sort. So this is the code for the merge sort, I think. So this is working fine, but we have to find another thing, like we have to find what is the value, what is the count value, like for every array I, what is, how many number of reverse pair are there. So what we can do, we can actually do something like we can also make one more part, like corresponding to every index we can have a count to it. So what we'll do that we will let's say okay, so as we have added all the indexes here, similarly we can do one more thing. We can start again with the I from 0 to 0, and as you know that here what is that we know that all the index of the array 1 will be smaller than the index of the array 2. So we just have to compare elements from array 1 to array 2, not from array 2 to array 1. So that is clear, I believe. And we'll performing okay, we've started. We'll perform something like the same, that and j is smaller than m. Okay, and in this we'll be checking if array I is greater than 2 times array 2j. Okay, if it is greater than, then we know that this is the point where our count is where our count will increase for the array I, and we know we don't have to do that for array j. And also we have that when we would have the first array 1, so we would have already calculated the values for the array 1 while merging it. So let's assume that in our this array it's not that there is only one value, so we are keeping like the two values. Okay, so how we are keeping, we will be taking a tuple. So a tuple will be like we will keep the value in the reverse sorted order, and its value from the earlier, let's say array 1 we had. Okay, array 1, and so earlier it would have some number of count of the reverse sorted value. Okay, so array 1 0, and it would be like array 1 and 1. Okay, so this is our value that we are being adding. Similarly we will be adding the same thing, we will be doing same thing for the j, that we'll adding we are keeping in the first index sorry, array 2. Okay, so we are keeping the first the 0th index with the value, and the first index with what its number of the reverse pair value for this particular for this particular index. Okay, and we'll be doing the same thing, I think. Let's do it. Copy it, paste it there. Similarly copy it, and so we on the second index, as you know, we are keeping the count of the reverse count. So now how are we calculating the reverse count? So if the array is already merged, let's say for array 1 and array 2, the reverse, it would have counted in the merge section of that part. But let's say for when it will be just the one element in array 1 array 2, so in that case we will check for that one particular element only, and if it holds true, then in that case what we will be doing, so we'll be adding the count, the reverse count. Okay, reverse count as the m minus the index of j. So you know, if it is the last index, so it would be, let's say there is only one element, so it should be 0 and the m will be 1. So in that case there should be one element. If there are 10 elements and it is at the and j is the fifth element, so in that case j would be 4, and so we know that from 5 to 10 index, so it should be, so there will be 6 elements. So in that case we will get our reverse count. Now what we need to do, that we need to update the new array value with let's say where would we don't know where we did added the new array index. So actually what we can do, here is okay, we can perform this operation before performing the operation for the merge sort. Okay, so in that case, let's say okay, keep this here, and we just need this n and m to be outside, to be at the top. So here what we can do, we can calculate the reverse count, and what we can do in the array 1 itself, at array 1 I index, here we are comparing with its 0th index only. Okay, array 2 0 index. Okay, so we will be updating the because you cannot update the tuple, so we'll be creating a new tuple with the value. This value will be same, the value at the index will be same, it's just that the earlier value of, will be adding the reverse count into the earlier value of our with the earlier value of reverse count that we have stored while merging this array 1 in itself. So that is our condition. So if this is the case and we have found that array I is greater than, so it could be that the next index of the array first could also be greater than 2 times the array 2j. So in that case we will just be increasing the I. If this is not the case, then we need to go to the next index at the j, and we know that other is smaller than only it is reverse sorted, so next element in array 1 will be smaller, so we don't need to worry about increasing the I. So this is how it will be performed, and if any of these condition reached, then we know that we cannot perform any more operation from there. So this is how we are going to update the reverse count, and finally we are just going to add whatever is the value. So we will be comparing, make sure we will be comparing with the 0th element, and that's how I think that would be our part, and we will just returning this new array. And this is how okay, I have already added, but so this is how we will be performing the merge and split. So, and as you know that this merge is taking m plus n means basically the n times, like it will totally taking at max, it could be like the size of the actual nums array, and this would also be at max can be size of the actual nums array. So it would be basically as the size, so it will be 2n, basically we can call it n, and this operation of the split will perform the log n times, because we are dividing it in half every time. So I think in this case we will get our answer in n log n times. Okay, and now I think we can just so our answer should be an array. We have to count the total number of reverse pair. Okay, so let's say our answer is 0, and we got a new array from the split. Okay, we got the new array from the split, and also when we are returning it here, so if it is the same, so in that case there is no reverse pair, we are just going to return the 0 if there is only one element. So that's okay. So let's do the self dot split, and we will be starting from the 0 and length of nums -1, that would be the last index that we are looking for, and then we will be passing the nums. Okay, and we are not passing the list of int now, we are passing a tuple, so it would be like a tuple of int and int. Okay, I think it should be like this, I believe. And for x in array, answer will be just adding the x, the first index of the x, and then we can return the answer. I think this should work. Let's see if it will work or not. This one never closed. Let's debug it on 24. Okay, yeah, while copying we did mistakes, so let's try. Okay, now there is one more. I don't think we need to provide the tuple. Let's try without the tuple. Let's see what new error comes. Okay, let's not provide. Actually, I not sure about like returning indexes, current user returning indexes, so let's go without them only. For solution is not iterable for x in array. So this is the error that we are getting. Okay, let's try to solve it. So it's basically saying it's not iterable, map of iterables. Okay, let's try to print the values. Okay, print new array. Okay, and also let's print it here, print array. Let's see why it's coming. And okay, I think we move the infinite. Actually they are going into the infinite loop. Let's see if it's solving this one. No, it's not solving this one. Okay, let's see, maybe the problem is like okay, but this should show its error, I believe, because here we have mentioned the array only. I think I have not done that mistake again. So the same error is coming, and answer is like object merge at. We don't have object merge at. Okay, maybe yes, this is the error. Then how it is work means like it should have said that there is no function called merge. I don't know what is it's coming. Okay, solution must take 3 positional arguments, but 4 were given. Okay, we had given self inside, not outside, and that was not chaotic. And let's say okay, this issue was supposed to become, because similarly I believe we have not created the same error at other places. Okay, list index is out of range for a new array. Okay, so what are we doing? Okay, new array while j is smaller than n. So I think we have the value at j smaller than n. New array dot append array 2j, array 2j1. Oh, this should not be an issue. Oh my god, yeah, right, m. It is supposed to be m. Let us see what is printing, etc, etc. Okay, so now it's running. Let's try to submit it and let's see how many of our cases pass. Let's remove the print, it will take the extra space. Okay, let us see. As the solution is in n log n, so I don't think TLC should come, right? It's got accepted, so okay, that's fine.